Hello friends, this is Asmit Goel and I'm back with another video where I'm going to explain the model and how we are going to add seismic loading to our model. In the earlier video, we have already added live load, dead load and the wind loads to our building. Now in this video, I'm going to explain you how I'm going to add seismic loading to the building. This is a part of an assignment of the course Structural Foundation and Analysis from Skyfi Labs. So let's move on to the ETAP software and let's see how seismic loading is being added. For the seismic loading, we are going to define the load pattern of seismic. The seismic loading has been defined, as you can see, according to the IS 1893-2000. We'll go to the modify lateral loads and we'll apply it to X and Y both the directions. According to the IS code, the seismic zone factor of 0.1 has been chosen and a site type of 2, which is based on the soil type which is there on the site, is being chosen. Now after that we have to decide the response reduction factor R, which is taken as 3. Now after defining the load patterns, we are going to do the analysis for the seismic loading. Since seismic loading is not applied to any member, so we can do the analysis directly. So we can do the analysis, but for doing the analysis we have to choose the load cases to run. Currently, I've also applied the response spectrum function, which is going to be the next step of our building. So I've already run the seismic design and analysis. So we'll cancel this for now and we'll apply the response spectrum function. To define the response spectrum function, we'll go to define function and response spectrum. In the response spectrum, as you can see, we have already defined the response spectrum function. If we see how we have defined the function, you can see the function name as response spectrum and the zone factor 0.1 from the IS code and the soil type as 2. We have already applied this function. After apply this function, we have to define the load cases. In the load casing, we have defined the response spectrum function. If we can see how we have defined this, we have chosen name response spectrum and load case type as response spectrum. Then we have applied two loads for X and Y both the directions and a scale factor is decided. The scale factor formula is taken from IS code. After defining the load case data, we'll click on OK and our load case will be defined. After defining the load case, we'll go for the analysis. In the analysis, we'll set the load case to run. So as you can see here, we have defined we have been shown the response spectrum and seismic loading, and these are both the cases which are going to run. Since I'm showing only the seismic loading, so will not run the dead and live load. So let's run the analysis. Guys, the analysis will take some time because it's a 23-story building. You can see the progress on the progress bar below. The deformed shape of the building will be displayed in the 3D view. As you can see, the result has been displayed in the 3D tab. Now, as the analysis is done, we can see from the display option in the force and stress diagram, all the diagrams can be seen from here, the shell stresses and forces, how the system is behaving for different values. For now, we'll not look into this and move on to the design. We'll design the concrete frame design according to the IS 456-2000. As you can see, the design code has been chosen as IS 456-2000. We'll click OK and move on to the design check. In the concrete frame design, we'll choose Start Design Check. and the design check will start. Since we have not taken some of the results from the analysis, so this dialog box is showing. We click OK and the design has been started. As I have already explained in the previous video, this red bar shows that design is being in progress, and according to the bar, the different elements of the building is being checked. After doing the response spectrum function, we are going to explain another method of doing analysis by time history function. Both of these methods are doing the dynamic analysis, but response spectrum functions gives more accurate result. We can use a time history function only when we have the time history data available. So as you can see, the design result has been displayed as a longitudinal reinforcement. If we can zoom in, we can see the different details of the design. So our design for the response spectrum function has been completed, and as you can see, no notification has been shown for any member failing, and we can check from the design, concrete frame design, and verify all members passed. It will show that all the members has passed. So the notification come all concrete frames pass the design check. So let's move on to the next method of doing the analysis by time history method. For doing the time history method, we are going to define another method and function. First, we have to change the load pattern. In the seismic load, earlier we have applied the wait. We have to unlock the model. Okay, now let's move on to the load pattern and change the seismic loading properties. Since the time history method is only applicable in one direction, we'll take only in the x direction, seismic load in the x direction. Other properties will remain the same. We'll click OK. Now we are going to define the time history function. In the define function, we are going to define time history function. Since we have a file from the an example file, so we are going to use that file for defining the function. In this, we are going to name our function as time history. Actually, we don't have to give this name. If we browse for the file, we can have the file directly. This is an example file which we have obtained from the course. So we are going to use this file. As you can see, the time history name function has been defined automatically. Now we have to define a few things here. We'll use the header lines as 9, which because of the file has a header line 9, and number of points we are going to use as 1. We are going to use a fixed format here in the format type and use a character type of 10, which is the default value. We click on OK, and our time history function will be defined. Let's click on OK. After this, we have to go on define and load cases. As we no longer need this response spectrum function, so we'll delete this function and we will define another load case. Here we are going to use the name time history function. We'll use the properties of time history function from here. Now we have to add a new load pattern. Here we are going to use the name application acceleration and function as time history, which we have defined earlier. For the scale factor, as we used in the previous function, we are going to use a value of 1663.5. Okay, rest of the things will remain the same and we have defined the load case of time history. Click on OK and let's move on to analysis. In the set load case to run, we will again not run the analysis for dead and live load. Let's run now. So the analysis is in progress for time history data function. Once the analysis is complete, we are going to do the design. So an analysis is complete. Let's move on to the design. In the design, concrete frame design, we will go on view revise preferences. As you can see, design code again is IS 456-2000, which is for the design of concrete members. We'll click on OK and start the design. Start design check. This will again take some time because we are having a big building of 23 stories, so this will take a few minutes. As you can see, the design is completed and we have been shown no notification about any member failing the design check. And as from the design, concrete design and verify all members have passed, we can see that all concrete frame passed the design check. If any error or message is shown that any of the member failed, then we have to iterate again and check for the design. Next, there is an option on tabs to display the reports, the project report, which has been generated automatically for the given model. If we go onto the report tab and double click on report project, it will start creating the project report. As you can see in the tab below, the progress of the report is going on and we will be shown another tab for the report. As you can see, different sub tabs for the report has been displayed. The work is in progress. Since the report file contains all the sections and details about the project, so it will take some time to load. So as you can see, after the design, report viewer is a new tab created for the report of the project. In this, we have a list of tables and all the sections and the details of the plan, which is created automatically and is very useful. So our design for the seismic loading and the wind load has been completed. Thank you.